Hello students, today in this video we are going to learn a new topic and the working principles of cooling towers. See, coming to the cooling tower, how it is going to be useful in power plants by using of this Rankine cycle. See here, in previous classes I have explained you about the Rankine cycle, how it works in thermal power plant. See how the cooling tower is connected to this Rankine cycle. See here, in the previous classes we have learned about the four main components of boiler, turbine, condenser, this pump, and these are the four components which we have seen in the previous classes about the Rankine cycle. See, when we are going to feed water into the boiler converts the feed water into steam, and the steam super saturated steam enters into the steam turbine where the work has been takes place, and it the hot steam enters into the condenser with some pressure and temperature, with high pressure and high temperature. See here, in the condenser the phase is going to be changed, and the what is the saturated steam entered from a turbine is going to be converted into liquid form, and it is going to be cooled by using of this cold water coming out from the cooling tower. See here, in this video we are going to learn about this cooling tower, how it is going to be used in the thermal power plant. This is what the from cooling water tower. What is the hot water? What is the hot water we are coming from the steam turbine is going to be entered here into the cooling tower, and again it cools in the cooling tower, and again it by using of this cooling water pump it is going to be circulated into the condenser here. By using of this it enters into the hot well, and again the recirculation of the Rankine cycle is done here. See, what does a cooling tower do? Cooling towers are used to transfer heat from cooling water to the atmosphere. See, in the cooling tower, here we are having a cooling tower. In the cooling tower, what is the hot water coming? What is the hot water coming into the cooling tower? See here what is happening. In the cooling tower, it rejects the hot from the hot water, and it cools by using of the air entered into this cooling tower, and it gives the cooling water to the condenser again. This is what we are studying about the cooling tower. See here, cooling towers are used to transfer heat from cooling water. See, we are going to transfer heat from cooling water to the atmosphere is nothing but of a cooling tower. It promotes efficient water usage, prevents environmental damage also. See here, where cooling tower is used. It is used mostly in power stations, oil refineries, petrochemical plants, and natural gas plants. Cooling water is continuously circulated through heat exchangers to absorb heat from processed materials and machinery. See, this is how it works here. We can observe here the hot water which is coming from the condenser is going to be entered into the cooling tower here, is going to be entered into the cooling tower, and the air from the atmosphere is going to be entered into this cooling tower. When the hot water and the cooling air which enters into the cooling tower are going to mix at a point, then the hot water is going to be cooled, and the air which enters into this cooling tower has taken away the heat from the cooling water, and it rejects to the atmosphere. This is what after taking away the hot heat from the water, heat from the water, the cooled water is enters into the condenser again. This is what the working principle of the cooling tower, how we can show here. See here types of cooling towers. Cooling towers cool the warm water discharged from the condenser and feed the cooled water back to the condenser, what I have shown you there in the diagram itself. We are having different types of cooling towers here. We are having natural draft cooling towers, mechanical cooling towers. Coming to mechanical cooling towers, again it has subdivided into forced draft cooling towers and induced draft cooling towers. See here, coming to the natural draft cooling tower, see the cooling tower is used to cool the water coming out from the condenser here. See here, hot water from condenser is going to be entered into the cooling tower, where the fine sprays, by using of these fine sprays, the water, so the water which is coming from the condenser is sprinkled upon to this cooling tower, upon to these hurdles. See, upon to these hurdles, and the air which is enters into this cooling tower, the air from the air which is entered into the cooling tower from the atmosphere is taking away the heat. The heat is going to be exchanged that from cooling water to the air. The water, the air, when enters into the cooling tower, it takes the heat from the water which is coming down into the cooling tower, and it evaporates to the atmosphere. The hot air is going to be evaporate outside, and the remaining water is going to be entered into the sump here, and it is going to be sent to the condenser again by using of this pump. This is what about the natural draft cooling tower. Natural draft means how the air, without any force, without any external agent, the air is going to be passed into this cooling tower. Since for that we are going to name this as natural draft. See how this air is going to be entered here means, in the cooling tower we are having some temperature, and in the atmospheric in the atmosphere we are having some different temperature. See here in the cooling tower, what is the temperature we are having is higher than that of the temperature which is outside the atmosphere. See here, the outside air is very cold, and the air which is inside the cooling tower, the temperature is very high. So as there is some difference in between the temperatures and pressures of the cooling tower as well as in the atmosphere, by the difference of these temperatures and pressure, the air is directly enters into the cooling tower here. We can observe the, in this way we are going to tell these as a natural draft cooling tower. See, this is what the original cooling tower which we can observe in thermal power plants. See here, in this type of, in natural draft cooling tower, what is happening that in this type of cooling water tower, fan is not used for circulating air, but here by enclosing the heated air in the chimney, and it will create pressure difference between heated air and surrounding air. See that what I am telling is that there will be some pressure difference. There will be some pressure difference between heated air and surrounding air, means inside the cooling tower as well as in the atmosphere we are having some pressure difference. Because this pressure difference, air enters into the cooling tower. As we are having some pressure difference in the cooling tower and in the atmosphere, due to the pressure difference, the air directly enters into the cooling tower. It requires a large hyperbolic tower, So capital cost is high, but operating cost is low because of absence of electrical fan. This is what about how we are naming these as natural means without any external source or without any usage of fan. We are going to the air is going to be entered into the cooling tower due to the pressure difference is nothing but of natural draft cooling tower. See, coming to here, natural draft cooling towers are having some advantages as well as some disadvantages here. Coming to the advantages, its operating and maintenance costs are less since no fans are needed. See here, we are not, as the name itself is defining that natural means we are not using any external agent such as fans and other equipment. Without using any external equipments, we are using the air is directly enters into the cooling tower. As we are not using here the fans, its operating and maintenance costs are very less. It creates its own draft, assuring efficient operation even when there is no wind. Also, we are going to create the own draft in the cooling towers. See, it has the natural draft cooling towers are having longer life. Some of the disadvantages of this cooling tower are high capital cost. This is very somewhat very much cost, and performance varies with the seasonal changes. See, with the seasonal changes, the performance is going to be dropped or can be increased. This is what about the natural draft cooling tower which we can study. And coming to the next one is about forced draft cooling system. In the name itself, it is telling that the force. In the previous one we have studied naturally. It is naturally doing, but here we need to force the air into the cooling tower. See here the process is same as that of natural cooling tower, but the only the difference here is that we are keeping here this FD fan. See here we are keeping here the FD fan. See, in the same procedure is there for both the natural and as well as for forced draft cooling towers. The hot water is coming from the condenser, and by using of this press, the hot water is sprayed upon to the cooling tower, and when from the atmosphere the air is sucked by using of this FD fan, and by using of this FD fan the air is going to be entered into the cooling tower, and the air is rises up, and when the air is going to be raised up, what is the hot water coming down are going to meet, means due to some convection process, these hot gases in the hot water, the heat from the water is going to be exchanged into the air, and the air takes this heat into the atmosphere, and it appears the hot air out with some atmosphere. See here, after that, after the air has been entered out with the hot air, then the water remaining is come down, and it is cooled water to the condenser, and it again sends to the condenser here. This is what about forced draft cooling tower, that what is happening here. See, the we are using fan here, means by using of this fan we are forcing the air into the cooling tower, and after the air enters into the cooling tower, the air moves up in the upward direction, and the hot water is coming in the downward direction. When the air is moving in the upward direction, due to the convection process, the hot gases or the hot water and the heat which is in the feed water is collected by this air, and this air is entered into the atmosphere, and the remaining water is collected in the collecting tank, and it is sent to the condenser again for recirculation purpose. This is what about the forced draft cooling tower. In the thermal power plant, this is the original cooling tower which we can observe carefully. These are the fans which we can observe here. By using of these safety fans, we are going to suck the air from the atmosphere and some entering the air into the sending the air into this cooling tower. This is what about the forced draft cooling system. And see here, mechanical or forced draft cooling. In this type of cooling tower, fan is used to circulate the air. In the natural circulation, we are not using any fan, but in the mechanical or forced draft cooling system, we are going to use fan to circulate the air. When power plants runs on peak load, it requires a very high rate of cooling water, as the cooling water is very required when it runs on peak load due to heavy temperature. When it is running, when the plant is going to runs on peak load, the temperature and pressure is going to be raised. When temperature and pressures are going to be raised, we need cooling water for cooling purpose. So that we are using here a fan to circulate the air. To rotate fan, it uses motor with a speed around 1000 rpm. Motor we are going to use for rotating of this fan. Working principle is same as natural draft cooling tower, what I have said you now. Only difference is that here fan is mounted on the cooling tower. See here, here we are mounting a fan at the cooling tower at the only difference is that here fan is mounted on the cooling tower. If fan is mounted on the top of the tower, if the fan is mounted on the top of the tower, then it is named as induced draft cooling tower, which is most popular for a very large capacity installations and installation and requires large capacity of fan. Means here we can observe in the diagram that when these fan when these forced FD fan is kept at the top position of the cooling tower, it is going to be named as induced fan or induced draft cooling system. The procedure is same for induced draft also, but the fan is going to be kept where for forced draft we are keeping fan at the right side of this cooling tower. But for the draft induced draft cooling tower, we are going to keep at the topmost position. See here. So forced draft cooling water contains horizontal shaft for the fan, and it is placed at the bottom of the tower. And the induced draft cooling tower contains vertical shaft, and it is placed at the top of the cooling tower. So we can observe that here for the forced draft cooling tower, we are having horizontal shaft for the fan. For that, it is placed at the bottom of the tower. And induced draft cooling tower contains vertical shaft, and it is placed at the top of the cooling tower. See here, forced draft cooling tower is having some advantages as well as some disadvantages. Coming to the advantages, it is more efficient. Problems of blade erosion are avoided. Fan is located at ground, so more safe. Vibration and noise are less as mechanical equipments are set on a solid foundation. These are some of the advantages here for forced draft cooling tower. And some of the disadvantages is possibility of recirculation of hot, humid exhaust air coming out from the top of the tower is way the disadvantage for forced draft cooling tower. And fan size is limited to 4 meters. Possibility of ice formation on fan blades in cold weather is one of the disadvantages for this forced draft cooling system. See here, coming to the induced draft cooling system, this is the third induced draft system and draft cooling tower. In this, we are having two types. That the first one is about the counter induced draft cooling system. See here, what I have said you that in the in the cooling see here, in the forced draft cooling system, we have placed these fan at the bottom of the cooling tower. But for induced draft cooling tower, we are placing these fan at topmost position of the this cooling tower. The procedure is same as that of natural draft as well as for forced draft, But in natural draft, we are not using any fan for getting air into the cooling tower. But in the forced draft cooling tower, we have used a fan for entering the air into the cooling tower at the bottom of the cooling tower. But coming to here in the induced draft cooling tower, we are using the induced fan at the topmost position of the cooling tower. See here, the procedure is same, that hot water is coming from the condenser and it enters into the cooling tower. After entering the hot water into the condenser, from the condenser, when the hot water from condenser enters into this cooling tower, the hot water is sprinkled upon to the cooling tower. And what is the air which is entering, which is going to be entered into the cooling tower by using, due to the convection process, the heat exchange takes place here. That from the water, the heat is going to be transferred into the air, and it the some of the water has been converted into water vapor, and the air, with this air, the water bubbles or water vapor formation is going to be taken out the hot air into the atmosphere here, and the remaining water is collected in the collecting tank, and again it is going to be circulated into the condenser for reuse of this hot water, cold water. This is what how the cooling water is going to be. Cooling towers are used in the thermal power plants for recirculation purpose of this cooling, for doing cooling purpose. So this is the induced draft cooling tower which we can observe in the thermal power plants. See here, we are having the hot air enters here, and the air is coming from the atmosphere into the cooling tower, and the heat is going to be rejected from water, and the convection heat exchange takes place in between the air as well as water, and the air takes these heat and transfers into the atmosphere. This is what about the induced draft cooling tower. And in the induced draft cooling tower, we are having cross. In the induced draft cooling tower, first we have studied about the counter, and in the induced draft cooling tower we are now studying about cross. Means, see here, the spray eliminators are in the cross section. In the cross section, see here, this is also the same procedure, same as that of the induced draft cooling tower. Induced draft cooling tower counterwise, and the cross also is same as that of counter. See here, the hot water from condenser is enters into the cooling tower. Here, by using of these sprays, by using of the spray eliminators, the hot water enters into the cooling tower, and the air enters into the cooling tower here. See, the air enters into the cooling tower. When the air has been enters into the cooling tower, some heat exchange takes place in between water and the air, and the air takes away the heat from the water, and it's uh, escape into the atmosphere with the hot air. This is what here in the induced draft we are using fan at the topmost position of the cooling tower here. See here, the hot water from condenser, how it enters into the cooling tower, and these are the water sprayers. What is the hot water coming from the condenser, it is going to be sprayed into the cooling tower, and the air is going to be entered here, and the water which is coming down, and the air which is moving upward direction, there some heat exchange takes place in between the heat water and the air, and the air transfers the heat from the water, and it escapes into the atmosphere with this hot air. This is what about the induced draft cooling tower cross section. See here, we are having some induced draft cooling tower is having some advantages. See here, coldest water comes in contact with the driest air, and the warmest water comes in contact with the moisture. The recirculation of hot humid air is not a major problem. See here, large fan size can be used here, and lower first cost due to the reduced pump capacity, capable of cooling through a wide range. These are the some of the advantages of induced draft cooling system. Coming to the induced draft cooling tower, we are having some disadvantages also, same as that of advantages. See here, not economical up to the capacity of 15,000 liters of water per minute. Higher power motor is required to drive the fan compared to the forced draft. Here we need the higher power motor in the induced draft cooling tower. See, maintenance cost is high, and the fan bearings need to be cooled. What are the bearings which we are using for the fan here needs to be cooled here. This is what about the induced draft cooling tower. And coming to here, some of the terms related with the cooling tower, nothing but a fill and a drift. See here, the hot water from the condenser is sprayed through the nozzles over a series of horizontal bars called fill or packings are there, which we can observe here in the diagrams. See, yes, we are having the packings. This is nothing but of a fills and drift. When the air flows from bottom to the top of the cooling tower, it carries fine water droplets along with the air. These fine droplets of water are called drift. Means when the hot water is coming down, the air which is moving upwards, it carries fine water droplets uh, up to the atmosphere along with the air. This is what some of the related terms with the cooling tower. Since in this video we have learned about two things, that what is meant by a cooling tower, and where the applications of the cooling tower, where the cooling towers are used, and how does it works here, and what are the types of cooling towers we are having, how the natural draft cooling tower works here naturally by sucking the air from the atmosphere, how it works, and coming to the forced draft cooling system, how we are using the FD fan here. By using of this FD fan, how we are going to suck the air from the atmosphere, and how the heat is going to project from water. See here, and coming to the mecha forced draft, we have studied some advantages and disadvantages. And coming to the induced draft cooling system, we have shown you in two ways, that in counterways as well as in crossways, that how the hot water enters from the condenser into the cooling tower, and how the air enters here, and where the fan we have kept here for the induced cooling tower, and how the air is going to carry away the hot air from the cooling tower to the atmosphere. This is what about the cooling tower counter. And coming to the induced draft cooling tower cross way, in the same way as that of induced draft cooling tower counter, same as that of counter, that the hot water from condenser enters into the cooling tower, and how the air carries away the hot water in the water droplets in a fine way, and how it carries the hot air out into the atmosphere, we have studied in this video. This is what about this is what about how we have learned about the cooling towers, and these advantages and disadvantages of natural, forced, and induced. This is what which we can observe here, that how what is a cooling tower, that cooling towers are used to transfer heat from cooling water to the atmosphere. See, in the natural draft cooling tower, as well as in the forced draft cooling tower, as well as in the induced draft cooling tower, the procedure is same, but in the natural draft, the air enters into the cooling tower directly, without any external agent. Without using any external agent means such as fans. We are not using any fans in natural draft cooling tower. See here, without using any fan, we are going to get the air from the atmosphere. Why? Because how the air enters into the cooling tower means as there is a pressure difference in the cooling tower as well as the atmosphere, we are having the pressure difference. Due to this pressure difference, the air directly enters into the cooling tower here. And coming to the mechanical draft or forced draft cooling tower, see here, the cooling tower requires fan at the bottom of the cooling tower. It requires the fan. By using of this fan, FD fan, by using of this FD fan, the air is collected from the atmosphere and it sends the air into the cooling tower. And we know the procedure that the water, hot water which is coming from the condenser is sprayed upon to the cooling tower, and the air which is coming up, what are the hot water coming down, the air which is coming upward in the upward direction carries away the hot air outside to the atmosphere, and it gives cold water to the condenser again. See, this is what about what we have studied here. In the induced draft, we are using the fan, but we are using at the topmost position of the these cooling tower, as the shaft of the fan is vertical. We are going to place this at the topmost position, and as the shaft of the fan for induced draft is vertical, it has been placed at the bottom of the these cooling tower. This is what about how we have studied about the cooling tower types, and about, see here, the working principles of cooling tower and the types of cooling towers. This is what about the cooling towers which we have studied in this video. In the next video, we are going to start a new topic, a new chapter, unit 2, in the next session. Thank you. If you are having any doubts, please contact me. Thank you.